The following is the third introduction to Math 241 Trigonometry. In this section, we will discuss the use of similar triangles in trigonometry. Okay, now similar triangles is something we learn in geometry, but here we will see what is the use of similar triangles in trigonometry. Now, suppose I have a right triangle as the following. Let's say this is my right triangle here. Now, and then suppose I draw a parallel lines to the parallel vertical line. So this line here will be parallel to the vertical line there, the vertical side. Let's put a name. Let's say this is A, B, C, and this is D, E here. Now, because D, E, and B, C are parallel, then we know that ADE, angle ADE, will be also a right angle. Now, similar triangles says this. Okay, couple things. Notice that in triangle ABC and triangle ADE, okay, now notice that angle B here is congruent to angle D here. Okay, that's one. Second, angle A here is congruent to angle A here as well. Well, that's identity, right? Now, but notice that if two angles in a triangle are congruent to two angles in another triangle, then those triangles are similar. Now, in fact, the word similar means this. It means same shape. This is a very crude definition of the word similar. Same shape, maybe different size. Okay, that's what a similar means. Now, but something we learned before, that if two triangles are similar, then first, corresponding angles are congruent. Corresponding angles are congruent. Like if we look back there, then you see that angle A in triangle ABC, angle A is correspond to angle A in triangle ADE, right? Also, angle B in triangle ABC is congruent to angle D. I think, yeah, I mean you see the direct angle, right? And also that angle C in triangle ABC is congruent to angle E. Okay, now that's the first thing. Now second, and this is the one is more important, the corresponding sides are proportional. This is the key and the foundation to trigonometry. Okay, in other words, AB corresponds to AD, right? Now the ratio of AB to AD is equals to the ratio of BC to what is the corresponding side? DE, which correspond to AC over AE. Okay, the corresponding sides are proportional. Now put it this way. In other words, if I have two triangles that are similar, okay, maybe instead of example, like an idea, try to make it into a larger one. Suppose I have a right triangle. It doesn't have to be a right triangle actually, as long as two triangles are similar, right? But let me use right triangle here. Let's say that these two triangles are similar, and it is by saying that they are right triangles, and the angle here, let's say the angle here is congruent to this angle here. Let me give them a name. They say this is ABC and this is DEF here. Now triangles ABC and triangle DEF are similar because they have two congruent angles, right? Now so they are similar triangles. Now once they are similar triangles, then the ratio of the corresponding sides are proportional. Okay, so let's say this is AB to DE. The length of AB to DE equals to BC to EF. Equals to AC to DF. Okay, now just for fun, suppose we know that this is, let's say this is 6 and this is 3. Okay, now once we know that these two are similar triangles, then if this were 5, what do you think this is? Well, this to this you multiply by 2, so here to there I multiply by 2 also. This will be 10, right? And of course, I hope you remember the Pythagorean triple. Like if you have hypotenuse 5 and one of the leg is 3, then the other one must be 4, right? And this will then be 8. Okay, so you can see that the Pythagorean triples actually not only coming from the fact that it satisfies the algebraic proof, but in geometry it also follows from the idea of similar triangles. Okay, but once we know that we have similar triangles, then the ratio, the proportions of the corresponding the ratio of the corresponding sides are proportional. Okay, if you divide by 2 here, then the corresponding sides here, you divide by 2, this divided by 2 give you that one. Okay, now what happened then in trigonometry is the following. It means that in future, if I know I have a triangle with a known angle, if I have a triangle here with this angle, let's say let's fix that angle theta, okay, and let's say the ratio is ABC, for example, okay, Therefore, if I have another similar triangle, approximately like this, and this is a right triangle here, and this is also angle theta here, then I know that the ratio of these three sides here must be proportional to the ratio of these three sides. Okay? In other words, if this A multiplied by N, then this P will be multiplied by N also. The one corresponds to C multiplied by N also. Okay? The ratio has to be the same. Okay? The ratio has to be the same. Now, very soon we will see three important trigonometric functions: the sine and cosine and tangent, and for certain angle they will always be the same ratio. Okay, but we will postpone that until introduction 6, 7, and 8. But for now, we know that the idea behind trigonometry actually similar triangles, in which if you have two similar triangles, then if you have two similar triangles to be similar, then the corresponding angles are congruent and the corresponding sides are proportional. Okay, this is the third introduction to Math 241 trigonometry, in which I try to explain to you the idea behind similar triangle, the idea behind trigonometry, which is the use of similar triangles.